All right, so we are picking up where we left off in the last recording, and we're talking about perspective distortions that can come from when you take and adjust your camera lenses. So you're either zooming or making them wide angle. So remember the human eye. Previous recording we talked about the human eye is equivalent to a 50 millimeter lens. So as you start zooming out to 80, 100, 200 telephoto type settings, you can cause distortion. And as you zoom back, when you start going into the 20, 15, 10, millimeter ranges, you can cause some other distortion. So an example of this here would be, taking a look at objects lined up, and suddenly now our depth cues become erroneous. So this example, we have a 70 millimeter, pretty close to 50 millimeter, so we're fairly close-ish to, what the human eyesight would see. And so we've got a line of soup cans, and what you end up with is you can see one can, the next can, the next can, each can getting progressively smaller, and they're lined up so that they're, just a few inches apart, and it still looks like they're a few inches apart. Now, when we go wide angle, suddenly our few inches apart makes them look many inches apart. Even take a look at the window. Here we're set up, and, the table kind of looks like it's right up against the wall, and you're really close to the window frame. Or the curtain, and here, the table, it looks like it extends back further, and now you've got more distance from the last can to that curtain. When we start zooming in, when we zoom into 135 millimeter, look at all the cans have become really close to each other. It's not as noticeable, the height of the cans. 24, look at how tall the first can is, and they get really short really quickly. They all look basically the same height. There's just some slight variations. There's a larger variation between the closest one and the next one, from the next one and the third one. And by the time we go to 300 millimeters, so we're zooming into these cans, we've stepped back a little further and we've zoomed into them. What we end up here is now they're almost straight across. I mean, there's still some variation in their heights, but they look like they're touching each other. They're like right on top of each other. You can do this at home very easily. A couple of water bottles sitting on your carpet. And again, here at the 55 millimeter setting, which is normal vision, the bottles are separated as we, get closer to the first bottle. And so we go wide angle. Not only do we see more of the room, but now suddenly these bottles look like they have become spaced out more. And where, we go and we get even closer yet and go to the 18 millimeter, we've spaced these bottles out even more. This here is your assignment for this week, folks. So your assignment for this week is to take three objects, line them up front to back. And I see this all the time. People will submit this assignment. I've been using this assignment for a few semesters now. What I want is, one object here and another object here, and that they're distance from each other. You leave those objects in place, and what you do is you take pictures where what you will try to do is zoom in or zoom out and cause these two objects or three objects to space themselves out differently, even though the objects stay in the same spot. Try and record what zooms you are using, what your telephotos are. If you have millimeters, great. If you're using your cell phone, just note then that it's you're using a 1x, a 2x, a 3x, whatever it is. But just take some notation. Do not line these things up side by side and try and do that, because they are not going to space out this way or this way as well. As what we're trying to do is create depth issues, because that's what we're talking about with focus oftentimes is also our depth, and where you can focus at various depths, dealing with our depth of field and perceptions at depth. So I do not want them lined up, side by side by side by side across. What I want is depth, where one is in front of the other, and what you're going to end up with is causing distortion where you don't know if one is close to you or further back from you based on using that zooming situation. All right, so just a little study here on visual cues and depth. Here we have a semi parked on the side of the road. How far away are we as the photographer standing from the semi? You've got some depth cues. You got a car over to the side there. So there's, there's traffic cone. There's a car. We can kind of, we don't know how far away the overpass is, but you get the overpass sign. So there's some cues here. Just think about this. How far do you think this is? 100 feet? 200 feet? More than that? Less than that? What are we thinking? What if I told you we're about 150 feet away? Now we've added in depth clues where, you know, every 50 feet we've put something. And again, you can kind of see where these signs don't necessarily line up with the triangles, but the signage are showing us our different depths. And suddenly now you realize, oh my gosh, you know, look at each one of these spaces is 50 feet. And they're approximately equal, but again, you know, as things get further away, we get that perspective and things kind of do get naturally compressed even with our normal lens. So this gets back to, you know, again, talking about our focal lengths. When we say that, you know, our normal eye is right around that 50 millimeter zone. We can fudge it a little bit. You know, the 35 to 70 is kind of considered the zone. 50 is considered optimal. Some manufacturers have 55 millimeter lenses, you know, whatever, doesn't matter. But we want to be in that sweet spot in that 50 millimeter range, plus or minus a little bit. When you start getting down, you know, below 35 millimeter, you get many of your common lenses you buy with cameras, they'll go down to 18 millimeter lenses. Well, now we're getting more wide angle, and a lot of lenses, you know, go up to like 80 or 100 millimeters when you buy them at the store. You know, so when you know, get the ones that just come with the cameras, what we call sometimes kit lenses. So, you know, by the time you get into that range, when you're in that 100 millimeter range or 80 millimeter range, you're kind of in the medium telephoto, a little bit of a zoom. And then we start getting over 100 millimeter up to a 300 millimeter. You know, we're looking at the true telephoto lens. Past 300 millimeters, you're getting into, you know, what we sometimes call the super telephoto. The idea here is when, you know, you want wide angle, that's perfectly fine for a lot of our landscape photography, some of our architectural stuff, that's great. But when we want to actually document something, what we call documentary photography, which CSI is, we're documenting our crime scenes. We want that 50 millimeter lens or so. You know, when you start getting into trying to get pictures of wildlife and trying to do sports or trying to do things where you want to be further back and not be part of the action and still view the action, that's where the telephotos start to come into play, because, you know, I want to be further away from the action with a telephoto. So from the CSI standpoint, we do use telephoto when we do some of our surveillance type work. We're going to hang back a little bit and try and snag photos of folks at a distance. But for the most part, our idea here today is crime scene photography, which means we want to be in that sweet spot of the 50 millimeter. So again, just kind of looking at this, you're saying to yourself, well, what are we looking at here? Are we looking at the forests or are we looking at the leaves? And really, you know, for the most part, we want to be looking kind of at the forest, but there comes time when we do close-up photography, we will use our specialized lenses for close-up to look at the leaves. All right, a couple different kinds of lenses that are out there. So here we have a autofocus only lens. So just, you know, as folks are coming out and about and kind of thinking about picking up lenses. So you can see this one here is a lens that does 70 to 300 millimeters. So this is more of a lens designed for telephoto use. Versus here is a lens that has actually a switch over here on the side for autofocus and manual focus. This is the kind of typical lens you get with a camera when you buy it at the big box store, where it's got an 18 to 70 millimeter zoom, and you can see they're actually you know, noted on here. You have your 18, your 24, your 35, your 50, the 70 is over here, and there's that little dot that shows what you're set at. So you would want to try and keep your camera set right close to the 50. Here's one where what you can do is you can actually adjust on the lens, the manual focus, autofocus. You can adjust also your aperture, your f-stops. So you actually have the ability to adjust the f-stops right here on this lens. As you can see, this is a macro lens. This is actually designed for taking close-up pictures. It's a 60 millimeter lens, so close to the human eye, but actually is designed for getting in close and zooming in on things in the close-up, so fingerprints and whatnot. The idea here is sometimes the camera, the electronics inside the camera, when you start getting in close, doesn't always recognize our apertures, and so we have to go into manual mode and start taking over some of that. And it's just easier to dial things in right here on the lens versus clicking away on the controls on your camera. So if you're not familiar, I mean, there's all kinds of different lenses out there. We have your 15 millimeter, kind of like a fisheye lens, all the way up to your 200 millimeter telephoto lens. And just kind of a good selection of different lenses that offer some different things. Oh, here's a 400 meter super telephoto lens even. We've got our macro lenses for getting in close. They actually sell straight up 50 millimeter lenses. Some manufacturers, 55, 57, 70, but they actually sell what we sometimes call a normal lens. So these 50 millimeter lenses that are designed to be fixed in at a specific thing. So just a reminder, our normal lens, most like the human eye, typically we were looking at 30 to 70 millimeters. Wide angle lenses, short focal lengths usually. You're looking at close-up objects, 10 to 35 millimeters. You even have stuff like the fisheyes, which really create an extreme a level of additional vision. Don't use those fisheye lenses in CSI too often. Telephoto lenses, zooming in on things far away. Sometimes, you get such a big telephoto lens that you actually need to have the lens mounted to the tripod. So we start getting into these. Now you are looking at surveillance type work. When we get into again, our lenses at the wide angle, we actually have some of our lenses that are designed for wide angle lenses that actually have magnification built into them. Those become now actually macro lenses, and they can actually zoom in on stuff. It's basically like putting a microscope on your camera that you can get in tight on stuff. Not quite as tight as a real microscope. You can't see cells, but we can see the actual details on our fingerprints. Mentioned the fisheye lens, so here's just kind of the distortion fisheye lenses have. It's kind of cool for a lot of your artistic pictures. They're neat. I don't have one, never used one, but I've seen lots of pictures with them. One other kind of cool thing that you can have out there is called a tilt shift lens. There is actually some use for tilt shift lenses in CSI work, and tilt shift lenses create these weird focus things. This is actually a real city street. This is not a miniature model. And the tilt shift lenses will create this where it looks like a miniature or a model, when in reality it's actually a city street. The tilt shift lenses, essentially you can see where the lens is canted off to the side of the camera. And these become useful when we take pictures sometimes of fingerprints on mirrors or on glass where we don't want weird reflections. Not regularly used in CSI, but we're starting to see more and more officers out there starting to look at them. Lastly, I want to talk about something called pre-focusing, where there are times where you have hard to focus on objects. And so what you need to do on your cameras is push the button halfway down and kind of get the camera to beep and tell you that it's in focus. And then you need to move to what you're trying to take a picture of. So sometimes when you have say the spatter on the floor here, the camera can't focus in on the spatter, but it can focus in, say, like on this letter H. So you would have the camera pointed at the letter H, you'd focus it, beep, and then you would move so that the framing has the blood spatter in the middle of your image, so that this way everything will stay in focus because the H is at the same elevation as the blood spatter, because it's literally laying there on the ground. And cameras tend to focus here at the center of the photo, and yet our ruler and the letter is a little bit off center. So that is what we're talking about in pre-focusing, where sometimes you're not going to be able to focus on something because it's kind of globulous like this blood spatter. So what you need to do is find something like a number or a letter, focus on that's on that same plane, and then just shift over, holding that focus, and then take a picture of what it is you really want. All right. So again, remember your assignment is to do the depth cues. So line things up front to back, not side to side. And in zooming, cause these things to suddenly go from sitting here to looking like they're here or here, even though you're not going to touch and move them. Do about 4 different zooms, put those in a PowerPoint, upload them, and I will give you some feedback. If you have any questions, as always, feel free to reach out. Otherwise, I will talk to you next week.